Have you ever wondered what it would be like if humans could breathe underwater? Imagine a world where we could explore the deepest trenches of the ocean without the need for bulky equipment or the fear of running out of oxygen. The tantalizing possibility of humans breathing underwater not only opens up a new realm of exploration, but also presents a host of implications. As we prepare to delve into this topic, expect comparisons, fascinating facts, and food for thought. As we dive into this fascinating topic, prepare to have your mind submerged in a sea of knowledge. To understand what it would mean for humans to breathe underwater, we need first to grasp how our respiratory system works. Let's start with the basics. The human respiratory system is a series of organs responsible for taking in oxygen and expelling carbon dioxide. This process, known as respiration, is vital for our survival. Our journey begins at the nostrils or mouth, where air enters the body. The air then travels down the throat through the larynx and the trachea. This is our windpipe, a tube that splits into two bronchi, each leading to a lung. Inside the lungs, the bronchi further divide into smaller branches called bronchioles. At the end of these bronchioles, we find tiny air sacs called alveoli. This is where the magic happens. Each lung houses about 300 million alveoli, which might seem like a lot. But we need every single one of them for efficient oxygen exchange. Oxygen from the air we breathe moves across the thin walls of the alveoli and into the bloodstream. At the same time, carbon dioxide, a waste product of metabolism, travels from the bloodstream back into the alveoli. From here, the carbon dioxide follows the same path the oxygen took in, but in reverse. It moves up through the bronchioles, bronchi, trachea, larynx, and out of the body through the mouth or nostrils. And just like that, we've completed a cycle of respiration. To put it simply, the human respiratory system is an intricate assembly line for oxygen intake and carbon dioxide expulsion. It's a continuous process that keeps us alive, happening around 20,000 times a day without us even thinking about it. But what about underwater? Water is about 800 times denser than air and contains significantly less oxygen. Our lungs, designed to extract oxygen from air, would struggle with the denser medium. Our respiratory system has evolved perfectly for life on land, but how does it stack up against those designed for life underwater? Life underwater requires a whole different set of respiratory adaptations. Let's look at the fascinating ways aquatic creatures breathe. Starting with fish, these creatures have developed a specialized respiratory system that allows them to extract oxygen from water. They do this using gills, thin-walled, highly vascularized organs that pull oxygen from the water and expel carbon dioxide. The water, rich in oxygen, enters the fish's mouth, passes over the gills, and is expelled through gill slits. This process, known as gill ventilation, allows the fish to breathe underwater. Now, let's move on to whales, which are mammals like us, but live in the aquatic environment. Unlike fish, whales have lungs and breathe air. They come to the surface of the water to inhale air through their blowholes, then hold their breath and dive. Some species can hold their breath for up to 90 minutes. When they resurface, they forcefully exhale, expelling a spout of air and water vapor. Then there are the amphibians, a group that includes creatures like frogs and salamanders. These creatures have a three-pronged approach to respiration. They use lungs like we do, but they can also absorb oxygen through their moist skin, a process known as cutaneous respiration. In addition, some species have gills, particularly during their larval stage. And then there are the sea cucumbers, which take a different route altogether. They breathe through their rear end. They take in water through their anus, which is then circulated around their respiratory trees, extracting the oxygen. What a diverse array of breathing mechanisms, right? Each of these creatures has adapted to their specific environment in their own unique way. From gills to lungs to skin absorption, and even breathing through the rear end, the animal kingdom is a testament to the incredible diversity of life. These creatures show an incredible diversity in respiratory systems, all tailored to their unique underwater environments. Now that we understand both human and aquatic respiratory systems, we can make a comparison. In terms of efficiency, it's a fascinating matchup. Human lungs are marvels of engineering, designed to extract oxygen from the air. Each breath we take sees oxygen absorbed into our blood, while carbon dioxide is expelled, keeping our bodies running smoothly. Aquatic creatures, on the other hand, have gills that extract oxygen directly from the water, a much denser medium than air. However, their gills are no less efficient. They're capable of extracting the tiny amounts of dissolved oxygen from water, which is about 20 times less than the oxygen in the air. When it comes to adaptability, aquatic creatures have an edge. Many of them can survive in a range of water types, from fresh to salty, and temperatures from the Arctic to the tropics. Humans, by contrast, are land-dwelling creatures. Our lungs are adapted to breathe air, and while we can hold our breath underwater for short periods, we can't extract oxygen from water. Now let's imagine, just for a moment, that humans had the ability to breathe underwater. Our lungs would have to undergo a significant transformation. They'd need to become more like gills, capable of extracting oxygen from water. But this would also mean losing the ability to breathe air. It's a trade-off, you see. To gain one ability, we'd have to lose another. And let's not forget the immense pressure underwater, which our bodies are simply not designed to withstand. So where does that leave us? Well, we may be land dwellers, not designed for a life aquatic. But our lungs are nothing short of extraordinary. They're incredibly efficient at extracting oxygen from the air, enabling us to live, work, and play. We might not be able to breathe underwater like our fishy friends, but we've got our own set of impressive skills. While we can't breathe underwater like fish, our lungs are incredibly efficient at extracting oxygen from the air. So what if we could breathe underwater? How would that change our lives? Imagine a world where you could dive into the ocean and stay there, exploring its depths without the need for an air tank. This ability could revolutionize human life as we know it. Firstly, let's consider urban development. If we could breathe underwater, we could potentially build underwater cities. These would not only offer a solution to land scarcity, but also open up a whole new frontier for architectural design. Imagine skyscrapers that extend not into the sky, but down into the depths of the ocean. Moreover, our recreational activities would change drastically. Water sports would be transformed. Surfing, sailing, and swimming would take on new dimensions. Scuba diving would be as easy as taking a walk in the park, and water polo might become a whole new ball game. The potential benefits of underwater breathing are not limited to human activities. There's also the potential for significant positive impacts on the environment. For instance, if we could live underwater, we might lessen our reliance on land resources, reducing deforestation and preserving habitats for land-dwelling species. However, it's important to note that this ability would also come with responsibilities. The underwater world is a delicate ecosystem, and we would need to ensure that our presence doesn't disrupt it. We would have to learn to live in harmony with aquatic creatures, respecting their habitats as we do our own. Furthermore, whilst it's exciting to imagine the possibilities, the physiological changes required for humans to breathe underwater are immense. So, for now, this remains firmly in the realm of science fiction. Yet, just as we have adapted to life on land, who's to say we couldn't adapt to life underwater? After all, evolution is a game of endless possibilities. The possibilities are endless and fascinating to contemplate. We've taken a deep dive into the realm of underwater respiration today. We've explored the intricacies of the human respiratory system, a marvel of biological engineering that allows us to extract oxygen from the air and expel carbon dioxide. We've journeyed through the vast oceans to understand how aquatic creatures, from fish to mollusks, have developed their own unique mechanisms to breathe underwater. We've compared these two worlds side by side, highlighting the stark differences and yet the underlying similarities in the quest for survival. We've seen how our lungs, designed to process air, are fundamentally different from gills, specialized for water. And yet, both systems serve the same essential purpose: to keep us alive. Then we've pondered the hypothetical. What if humans could breathe underwater? We've imagined a world of endless exploration, where the ocean depths are as accessible as the highest mountain peaks. We've contemplated the adaptations, the challenges, the opportunities that such a capability could bring. In the end, it's clear that while our lungs may not be built for underwater respiration, the human spirit is endlessly adaptable. We've sent astronauts to the moon, created submarines to explore the ocean depths, and we continue to push the boundaries of our understanding and capabilities. While our lungs may not be suited for underwater breathing, our imaginations certainly are. Thanks for joining this deep dive into the world of respiration.